Learning Objective 2.1 asks you to be very comfortable with something called the production possibilities frontier and opportunity costs. As we'll see, we're going to use the production possibilities frontier to analyze opportunity costs and trade-offs faced by an economy. The production possibilities frontier is a curve showing the maximum attainable combinations of two products that may be produced with available resources and current technology. Now remember, it's very important when you look at a curve to always remember what they mean. This curve, the production possibilities frontier, tells you how much you can produce, how much the maximum attainable combinations of two products using available resources and current technology. Let's see an example of that.
As mentioned in Chapter 1, economic models can be used to analyze various questions. So here in Figure 2.1, we'll use a graph to illustrate one of these simple models known as the production possibility frontier. Specifically, we're going to analyze the trade-off that Tesla Motor faces at its Fremont, California plant. Note, it has a choice or production possibility between two goods, sedans and SUVs. So we'll plot each one of these variables on each axis, sedans on the vertical axis and SUVs on the x-axis. Now it's also worth noting we'll have to make two assumptions. First, all resources will be used fully and efficiently, and second, all other resources or goods are fixed. If that is true, then we can go ahead and label our points. For example, if Tesla Motors wishes to choose nothing but sedans, point A, we simply plot the point. Then we can look at different other possibilities that Tesla Motor chooses to produce, which we will label B, C, D, and E. Once we connect the dots, we have simply our production possibility frontier. Yep, it's that simple. It's also worth noting when we're on the production possibility frontier, this is what we call an attainable or specifically a technically efficient point. Any one of those points, A, B, C, D, or E, are technically efficient. In other words, we can maximize our output based on all the available resources available to us, or in this case, to Tesla Motors. What about points below the production possibility frontier? Well, we describe these points, like point F, as currently attainable but inefficient, since it's not utilizing all the resources fully. What about points beyond the production possibility frontier? Say point G. Well, currently it's unattainable because we don't have the resources today to reach that point. The production possibility frontier can also be used to address various issues for the entire economy. Here we'll assume our economy only produces two goods, tanks, which we will identify as military goods, and automobiles, which we will describe as civilian goods. Here in Figure 2.2, we have our production possibility frontier for these two goods. Point A, or the y-intercept, where we produce nothing but tanks, 400, and 0 automobiles, or the x-intercept of 500 automobiles and 0 tanks. We can also look at various combinations all along the production possibility frontier as well. But let's turn our attention to the actual shape of this production possibility frontier. It's described as being bowed outwards. Unlike our figure from 2.1, there we had a straight line production possibility frontier. Why do we have this bowed out shape? It's due to increasing marginal opportunity costs, specifically of automobiles in terms of tanks. In other words, if we increase our production of automobiles, the opportunity cost or the trade-off in terms of tanks will increase. For example, let's see what happens if we increase our production from point A, where we have 0 automobiles, to point B of 200 automobiles. Well, the opportunity cost or the trade-off, the number of tanks we must give up, is 50. Now notice what happens when we increase our production from point B to point C. Again, we increase our automobile production by the same 200 as before, but now look at the trade-off in terms of the amount of tanks we have to give up. Here, it's 150. So notice as we change the same amount of automobile production, 200 each time, the trade-off or the opportunity cost is rising. Thus, as the economy produces more and more automobiles starting from point A, it experiences increasing marginal opportunity cost. Well, why is this? Well, some of our resources, for example workers, are simply better at producing one of the goods than the other. Thus, if some of our workers are better producing tanks and we force them into producing more automobiles, the opportunity cost is higher. So we will stay with our example of the overall economy to use the production possibility frontier to illustrate a very important economic concept, something called economic growth. So here in figure 2.3, we're going to have our typical production possibility frontier for our economy producing automobiles and tanks. Remember, we are currently assuming all resources are currently fixed. Thus, in order to produce more automobiles, we have to produce less tanks. In other words, we move along the production possibility frontier. So now we can use the production possibility frontier to illustrate what will happen if our resources, say our capital stock, or the labor force increases over time. Or for example, what if technology were to improve in the production of automobiles and tanks? Well, we simply shift out our production possibility frontier when these resources change. Notice, if we start at point A, we can now produce more of both goods due to a change in either the number of resources or technology. But what would happen if we increased the technology of only one of the goods? For example, what if technology only improved in the production of automobiles? Well, how would we illustrate this? Well, once again, we would shift out the production possibility frontier, but as opposed to a parallel shift we saw in the previous graph, here it's more of a rotational shift. Notice the y-axis, the number of tanks, does not change, whereas the x-axis, the number of automobiles, increases, again due to an increase in technology. In either example, shifting out the production possibility frontier simply represents one of the most important concepts in economics, known as economic growth.